Hey guys, this is the first video for Unit 5. This is on bonding, a very important unit that we will be spending a couple of weeks or so, will drag out over Thanksgiving break, and then you'll have time to wrap things up after we get back from Thanksgiving break. This is a very important unit that, again, leads into so much that we talk about in the second half of the year. It's, again, another very conceptual unit. You've got to know your vocab. I think many of you saw the importance of that in the last unit, so make sure that you are really not just writing the definitions down, but you're reading over them each day. It's something that's going to be super important for you guys. So just make sure that you are keeping up with that. So this first video is going to be 5.1, review / energy and bonding, kind of like setting up everything where else we're going in this unit. So let's just jump right in. One thing before we get into the notes, if you'll notice on page 4, you've already got a study guide for the different bond types. It's got the types of atoms that are involved, forces of attraction, how they come together. You've got different properties, different examples, relative strengths. So you have this already down here, and then down below you've got kind of the relative strengths of the bonds as well as the intermolecular forces, kind of where they fall in line. So it doesn't mean a lot to you guys right now, but this is going to be a great resource not only for this unit, but as we go throughout the year, you have this to go back and look at for review. So make sure you hold on to this. This is going to be a great resource for you guys. So let's talk really briefly, review. It's been a little while since we've talked about the basics of some chemistry that hopefully you have not forgotten. But basically, like, what is a compound? Okay, be thinking about what that is. Okay, it's a substance that has atoms of 2 or more different elements. That are chemically bonded. Okay, that's the big thing, is that they are bonded together. So a bond, if we break it down to its simplest form, it's just a force of attraction between the protons, okay, of one atom and the electrons of another atom. Again, that should make sense. Protons are positive, electrons are negative, opposites will attract. Really, all we care about, though, are those valence electrons. You saw in the last unit, the valence electrons are the ones that dictate the different properties, as well as the different trends and the patterns that the periodic table falls in. So those valence ones are the only ones we really care about. Bonds are formed as a result of a chemical reaction. So when you talk about or think about a reaction, that's what's happening. So RxN, remember, is just how I abbreviate reaction. One thing you got to keep track of, again, law of conservation of energy or mass or charge, all kind of lumped together in the same thing. During a chemical reaction, energy, mass, and charge cannot be created or destroyed. That means all three are going to be conserved. Now, this is talking about ordinary chemical reactions, which is the majority of what we will discuss this year. Only nuclear chemistry kind of goes against that, but that comes at the end of the year, so don't worry about it right now. Octet rule again, 8 valence electrons, 8 is great. Again, you guys all know about that. Pause the video, take the next couple of minutes or so, go through, answer these questions right here based on last unit. They should be pretty easy for you guys to go through. So pause it right now, go ahead and answer those questions. So, hopefully you've already answered those. Which noble gas would most likely to form a bond? Look at your periodic table. If you look at your periodic table, okay, I'm going to pull mine up. It's not going to be the Regents one, but it's all good. You guys have that. So if you take a look, now we know that most of the noble gases aren't going to bond, but as you go down, the electrons are getting further away, and if you look on your reference table, xenon right there has got a bunch of charges, so it can be forced to bond. So keep that in mind, that xenon would be the one that is most likely to, but again, they all don't want to. What do you think causes the noble gas to be more reactive as you move down the group? Again, you've got increased shielding going on from our last unit. right, those valence electrons are getting farther and farther away from the nucleus, so it's easier to remove them or to let them be shared or whatnot. Which element would most likely be able to form a bond with this noble gas? So if you looked on your chart there, xenon, you got +2, +4, +6. So it's going to be something that, you know, tends to want to gain those electrons. So which one of those elements listed there has got the highest electronegativity? That's going to be this guy, fluorine. Remember, chem is phan. Those are the ones that are most electronegative, especially fluorine. So it's because it's got the greatest electronegativity. All right, so that's a little review. Let's jump in and get going with the new stuff here. So energy and bonding, very important unit. Lots of different stuff that we will do in the second half of the year is related to this. So it's the energy that's associated with bonding. You can see here this little picture. You've got two atoms connected together. We draw it with like a line. So spontaneous versus non-spontaneous. That's kind of the two categories that we're looking at. So spontaneous bond formation is when energy is going to be released. Okay, so you go from a high energy state, all right, where you have unhappy atoms. Remember, they're lazy, just like we are. If you had the opportunity to, their choice to run a marathon or stay in bed, most people are going to stay in bed because we're lazy. Electrons and atoms are the same way. They go from high energy to lower energy. Okay, so where you get back to those happy atoms. Creating a bond creates stability. Okay, so not a lot of chaos. So you got kind of two types of reactions that we can talk about, and we'll talk more about those in the next unit when we do reactions. Exothermic is when energy is released. Okay. It's released as a product. So you can see it, it's over here on the right side of the arrow. There'll be more of that coming in unit 6 or 7 when we do reactions. Note when you have energy on the product side, okay, it looks like that. So you would write it in. It could also be called heat. Okay, heat and energy are synonymous. So heat equals energy. Make sure you remember that. They mean the same thing. Okay. Breaking bonds, though, is not spontaneous, means it takes energy to break those bonds. So energy is going to be consumed. So you go from lower energy to higher energy. Okay, so they're not happy anymore. That's why it takes energy. That's why you got to put it in. So if you rip apart two atoms, it takes a lot of energy. This is what we would call an endothermic process, where energy is, and I know I didn't leave you a lot of space, I'm sorry, it's where energy is consumed or needed as an ingredient to fuel the process. So kind of on the flip side to up here, where we have energy as a product, okay, down here energy is a reactant, so it's being used up. It's on the reactant side. Again, we'll talk more about all those specifics later on. So a couple examples, an ice pack would be chemicals combined, bonds are broken, energy is consumed. That's why you feel cold, because you're losing heat to the ice pack. Whereas on the flip side, if heat's released, that would be like a hot pack. Okay. So that's as far as we're going to kind of go in this video. Kind of the basics of what's happening with the energy. Make sure that you know spontaneous versus non-spontaneous. Spontaneous happens when you have bonds forming, because they're going from a high energy to low energy, so they're releasing it. Whereas breaking bonds is not spontaneous. You've got to put a lot into it to get out what you want. All right?